So in Chapter 7, we're going to be solving triangles once again. We actually had a chapter earlier in trigonometry where we solved right triangles. So the techniques that we're going to be learning in this chapter will allow us to solve triangles that are not right triangles. If they're a right triangle, we can of course use the Pythagorean theorem to find missing sides if we know two sides, and we can also use the SOHCAHTOA right triangle trig ratios. However, none of those relationships apply in a triangle that is not a right triangle. Therefore, we need two new relationships, the first of which is called the law of sines. The law of sines works in right triangles, of course, but we don't need it there. More importantly, it works in triangles that are not right triangles. The law of sines says that you can form a ratio between the sine of an angle and the side across from it. So as you can see here, the sine of A over A, or A over the sine of A, either way, it doesn't matter which one you put on top, the sine of the angle or the side, will be equal to the same ratio of angle B with side B and angle C with side C. Now, we actually will only use two of these ratios at a time when we solve for missing parts, and then we'll be able to cross multiply. So here's an example of the law of sines. Now, I can tell very quickly that this one is not going to be a right triangle because the two angles they've given me are 30 and 70, and that's 100, so that means this missing angle is actually 80 degrees. So we were given two angles, and we're supposed to find everything else. To solve the triangle means that we're going to find all the missing parts. Well, there's one angle left to find, and that's angle C. When they give you two angles, we know the sum of all three angles in a triangle is 180, so now if I take angle C and I add 30 and I add 70, I'll get that 180, the total. So angle C is equal to 80 degrees, as I mentioned earlier. Angles are labeled with capital letters, and the side across from them is the corresponding lowercase letter. You must show a step of work, so you must show the work for each answer. So typically this would be 1 point here and 1 point here. 1 point for the work and 1 point for the answer. Well, we have two other things to find, and both of those are sides. It does not matter which one we find first. So let's go ahead and find, well, let's see. Let's find side A first. We'll kind of go in alphabetical order. So to find side A, I would put side A over the sine of the angle across from it, which is 70 degrees. And that will equal, and now I want to use the information they gave me, so I'm going to use the 8.0 over the sine of 30 degrees. And then we're going to cross multiply. If we cross multiply and we're going to the nearest tenth, I find out that side A would be equal to 8 times sine of 70 and divided by sine of 30. To the nearest tenth, I get 15.0. Now, that's a rounded value, so I do not want to use that in my calculations. And once again, it would be 1 point for the work and 1 point for the answer. The last thing yet to find is the other side. We cannot use the Pythagorean theorem because it is not a right triangle, but we can use the law of sines. So I'm going to use law of sines to find side C. Now to find side C, I have to use angle C. So I'm going to put C over the sine of angle C. Now remember, angle C was not rounded, so that was exact. And that's going to equal, and again I want to use the information they gave us, so 8.0 divided by sine of 30. And once again we cross multiply. If I do that, I come up with little c equals, so I have 8 times the sine of 80 degrees, the unrounded value, divided by sine of 30. I get 15.8. And that's our answer. So once again, it would be 1 point for the work, 1 point for the answer. So this would be 6 points total. Let's do another example of this law of sines. So this is a bit of an application problem. In this problem, we're just supposed to find x. And again, we're going to use the law of sines. The x is across from the 5.7 degrees. So x over the sine of 5.7 degrees will equal, and then the 562 feet is across from the 85.3. We cross multiply. We're rounding to the nearest foot this time. I would have 562 times the sine, 5.7 degrees, divided by the sine, 85.3. To the nearest foot, I get 56 feet. And that's the law of sines. Law of sines can be used when you're given two angles and any side, and you can solve for all the missing parts. Okay.